Hi all, welcome to my channel. In this video, let's try to understand what the AWS AppMesh service is, what it is used for, what extra manual configurations we need to set up if we don't use this service. Let us also cover other services like CloudMap, Transit Gateway in this demo. Okay, imagine you have two microservices, Service A and Service B. Both are hosted in different AWS accounts, that is account A2 and account A3 respectively. Service A is internet facing while service B is not. This is what we have built in this demo. In order to set up this infrastructure, you have to have three AWS accounts, that is account A1, A2 and A3. Clone this repo and run this single Terraform command to set up this infrastructure. This will create resources across all those three accounts. In this demo, the client, that is the browser, will call the internet facing service A through the public IP of the service A's ECS task, like http:// public IP of service A ECS task : port 8080. That will open the main page of the web application hosted in service A. You will see a get country button, clicking on which you will get a country name. Clicking on the same button again and again will display a different country name randomly. This is a very simple app. The country name is not coming from service A. Rather, service A gets the country name by calling an API service hosted in service B microservice. Remember, service B is from another account. We have simply achieved this through services like AppMesh, CloudMap, Transit Gateway, ECS, ECR, etc. Now, imagine you have not used AppMesh. What would have happened? Will setting up this entire infrastructure not be possible without AppMesh? No. You can still set up this infra without AppMesh, but with a lot of manual configuration. That will be tedious. Let's talk about what would have happened if we had not used AppMesh in the first place. Point number 1. Friendly name. Service A contacts Service B through a friendly name in our current setup. That means Service A will make a call to the hostname serviceb.simpleapp.mesh.local. This is nothing but the virtual service name of Service B in AppMesh. Let's talk about virtual service, virtual node later. Let's simplify it. Service A needs the help of AppMesh to identify where the service B is actually running and route the traffic correctly to it. Simple. If there is no AppMesh, there is no service discovery, as obviously you wouldn't have used CloudMap. Okay, CloudMap can be used even without AppMesh in cases like ECS Service Connect, but in this case, you would not have used CloudMap, that is service discovery, if you had not used AppMesh. So in this case, service A has to know the private IP of service B, which is not quite correct because there would be multiple instances of service B ECS tasks. Those ECS tasks can be created and get killed as they wish, and you don't have control over it, meaning you can't really rely on private IP. So what's the other way? You have to have a host name which will remain constant. Well, virtual service of AppMesh does that by default for you. But without AppMesh, you have to set up a Route 53 private hosted zone or any DNS server and contact service B with a host name. It's a cumbersome manual setup. Number 2, 3 and 4 are service discovery, traffic routing and load balancing. Before seeing that, there are two parts in AppMesh: control plane and data plane. Control plane is just the configuration like virtual service, virtual node, virtual router, listener, backend, etc. While data plane is that extra container, also called the sidecar container, you run along with your essential container. In this case, the sidecar container is the envoy proxy, that is the data plane, while the essential containers being service A or service B. The control plane is responsible for managing the configuration and rules of the mesh, defining how services interact and distributing these rules to envoy proxies. So this is the control plane. The data plane consists of envoy proxies deployed with each service, which handle the actual traffic routing, load balancing, and enforcement of policies based on control plane configurations. If you have not used AppMesh, that means you lose the traffic routing, load balancing, and service discovery, etc. Number two, what is service discovery? We use CloudMap service for that. It means converting the friendly name to the private IP of service B via service discovery. Number three, traffic routing. What is traffic routing? Suppose service A has an option of sending requests either to service B or service C. The proxy should direct the traffic to appropriate services based on the host name in the request. If it is a request to service B, it will route the traffic to service B. If it is a request to service C, it will route the traffic to service C. Number 4, load balancing. As we saw, there would be multiple instances of service B ECS tasks. Suppose there are 3 tasks, and if service A makes 3 requests to service B, the envoy proxy evenly routes the traffic to all the instances. You have to do a manual load balancing in the absence of AppMesh. Last point, tracing, monitoring, and logging. If you have not used AppMesh, you would lose the tracing, monitoring, and logging provided by AppMesh. So we don't want to do all those difficult manual configurations, do we? That's why we have used AppMesh along with CloudMap. Without wasting time, let's clone the repo and run the Terraform apply command. Please note that all the infrastructure codes are under Terraform folder, and the service A web application and service B API are under app folder. Since we are using 3 AWS accounts, I have added access keys and secret keys of a test user from all those accounts in my local AWS credentials file. Let's check that by running these AWS CLI commands. Okay, all the 3 accounts are set up. I have already cloned the repo and I am inside the Terraform folder. I have Terraform installed. If you are cloning the repo for the first time, please don't forget to run the Terraform init command. I am in account A1 now. Accounts A1, A2 and A3 are in the organization, and A1 is the management account. Go to services and then search for RAM. Click on this. You can see that the trusted access is disabled. You can also see this setting from RAM. Go to settings. Here you can see that the trusted access for RAM service is disabled in the AWS organization. This is very important. This Terraform code will work only if you have trusted access disabled for RAM in AWS organizations. So you have to make sure you have disabled it. Now run the Terraform apply command from inside the Terraform folder. We have successfully created all the resources. Let's walk through each account. We are in account A1. In account A1, we have created an AppMesh. We created a transit gateway and we shared the AppMesh and transit gateway from account A1 to account A2 and A3. So these two resources are shared, AppMesh and transit gateway. And these are account A2 and A3. We are in account A1. The mesh owner is account A1. If you go to virtual services, you can see two services, service A and service B. The owner of service A is account A2, service B is account A3. That means since we have shared the AppMesh with account A2 and A3, the service A virtual service is actually created in account A2 and attached to the shared AppMesh. Similarly, service B virtual service is created from account A3 and attach to the shared app mesh. That's why we are weaving both service A and service B virtual services here. You can see both the services from account A2 and account A3 as well. That's because it's a shared app mesh. Similarly, we can view the service A and service B virtual nodes. The virtual nodes are nothing but ECS tasks. We'll go to account A2 now. In account A2, we have created a virtual service for service A and a virtual node for service A. You can equate virtual node with the ECS task. We also have accepted the app mesh and transit gateway resources RAM shared from account A1. Let's check CloudMap. We have created a service discovery namespace called simple-app.local and a service called service A. This service will contain an instance and that will have the private IP of the ECS task. Let's check that. This private IP and this private IP both are same. Also notice that domain name of this namespace can be different from the domain name of the app mesh virtual service. That is namespace. This namespace has simple app.local while the virtual service has simple app.mesh.local. So they can be the same domain or they can be different too. While creating, we inform ECS tasks that you have to use the service discovery simple app.local. Also, we inform AppMesh's virtual node that you have to use the service discovery simple app.local. Finally, we inform ECS task through the task definition that this virtual node is your AppMesh resource using the AppMesh underscore resource underscore ARN environment variable. So in this triangle setup, all the three, that is ECS task, AppMesh and CloudMap service discovery, are connected. In order to spin up containers in ECS task, we need container images. For that, we have built images and pushed them to ECR. In account A2, the ECR image will have web application code, while account A3 will have the API code. Now we need to create ECS tasks. We need task definitions for that. This is our task definition. It will have configurations for service A essential container and the envoy sidecar container. This user line is very important, without which the envoy proxy won't communicate with the app mesh's control plane. The proxy configuration specifies the settings for envoy proxy. Remember, all the ingress requests to essential container will come only via the proxy ingress port 15000. Likewise, all the egress requests from essential container will go via the proxy egress port 15001. So these are the ports of envoy proxy. You have now the images and task definitions ready. You need to create a ECS task under an ECS service called service A, which is under an ECS cluster called my ECS cluster. The ECS service should have permissions to do certain things, while the ECS task should also have permissions to do certain things. So we create an ECS task execution IAM role and assign it to ECS service, and create an ECS task IAM role and assign it to ECS task. Go to networking, you can see the task role and execution role. Let's see the roles. The ECS task role has this AWS managed policy and this customer managed policy. I have given a blanket permission just for testing purpose. Please don't use star wildcard in your projects. Similarly, the ECS task execution role has this AWS managed policy and this customer managed policy. Now we have the following setup. ECS tasks, AppMesh and CloudMap are created. The service A ECS task will call service B's virtual service in AppMesh. That is service b.simpleapp.mesh.local. The AppMesh will convert the friendly name of service B to a private IP of the service B's ECS task with the help of CloudMap. This process is called service discovery. Now, we have got the private IP of service B. When we try to communicate through this IP from service A, it will fail, as our setup in account A2 knows nothing about this private IP which is in account A3's VPC. How do we fix this then? We can connect both the VPCs in account A2 and account A3 either through VPC peering or private link, that is VPC endpoints, or as a third option we can use transit gateway. We have used transit gateway in our example as it will be better than the other two. It is clean, good for connecting multiple VPCs in a complex network structure. Please note that our ECS tasks in account A2 and account A3 are in VPCs. Also remember that the VPC in account A2 and VPC in account A3 shouldn't have a conflicting CIDR range. Otherwise, the transit gateway setup won't work. So you accept the RAM shared transit gateway from account A1 in both accounts A2 and A3. We have also created a VPC, added subnets under it, attached internet gateway to the subnet so that we will make it a public subnet which will let the users access the resources inside the subnet through public internet through a public IP. Remember, we load the web app from browser through internet like http / public IP of service AEC task port 8080. We create route tables and attach them with subnets. If you look at the route table closely, if you look at the route table closely, we are routing the traffic from service A to the private IP of service B through transit gateway. Remember, this private IP was resolved with the help of CloudMap. We are also creating security groups to allow traffic on port 8080. We have also created a Route 53 private hosted zone. Now, you might have this question. Why have we created the Route 53 private hosted zone? Will the traffic from service A reach service B only if we have this private hosted zone created? No, not like that. This private hosted zone is optional. In this setup, we have added an A record here with a dummy IP 10.10.10.10. This of course is not the private IP of service B, not even in that CIDR range. But why have we created this A record? This is because in order for the AppMesh communication to work, the service B's virtual service hostname, that is service b.simpleapp.mesh.local, should get resolved to any random IP in service A's container. This is a known issue. You can see the details here. Even though it is resolved to the dummy IP 10.10.10.10 in this case, it will be redirected only to the CloudMap resolved service B's ECS task private IP in account A3. So why have we created the Route 53 hosted zone? We created it as the A record is used to resolve the dummy IP. The Route 53 hosted zone is optional, as I said. We can even achieve this dummy IP resolution by mapping service b.simpleapp.mesh.local hostname with 10.10.10.10 in the ECS containers host file. Everything will work as expected. Okay, we have covered account A2. I'm not going to repeat the same for account A3. Similar resources will be created in account A3 as well, with a few differences, like service B is an API while service A is a web application. Now it's time to test the application. Let's load the URL http:// public IP of service A's ECS task :port 8080. Let's copy this. Okay, I have loaded the URL. The application is loaded now. When we click the get country button, we'll get random country names. Clicking on it again and again and again, we are getting different country names. So this web app is a microservice called service A, while the country data are coming from an API, which is a microservice called service B. We have achieved this entire infrastructure using AWS services like AppMesh, CloudMap, Transit Gateway, VPC, ECR, ECS, etc. Please don't forget to destroy all the resources. The resources are destroyed successfully. Thank you for watching this video. If you find this video useful and interesting, please do like, comment, share, subscribe, and press the bell icon. Thank you.